In the second video on solving problems on shear strength of soil, we will be solving a problem on triaxial compression test. A quick revision from the previous video. You can pause the video and just revise the formulae. The question is as follows. It seems a test was done on a soil and the data is given in table. First column, there were three tests done. First column is the chamber pressure, second is the maximum deviated stress applied by the load cell or the loading machine, and the third one is the pore pressure which is measured. We are supposed to find the total and effective stress parameters in the soil. So first trying to understand the problem and the given data. So the chamber pressure here is nothing but the sigma 3, the minor principal stress. The maximum deviated stress as discussed is delta sigma, and pore pressure is given which is U. We need to find C and phi, the total stress, as well as the effective stress parameters C dash and phi dash. Formula required here are sigma 1, which is the major, is the summation of sigma 3 and delta sigma, and effective stress equals to total stress minus pore pressure. So sigma 1 dash is sigma 1 minus U, and sigma 3 dash is sigma 3 minus U. So we'll solve this problem in a tabular form. So you can make two columns, one for total stress, another for effective stress. So to plot a Mohr circle, we require sigma 1 and sigma 3. So for total stress, sigma 3 is directly given the chamber pressure. Sigma 1 can be found out from the formula 1, sigma 3 plus delta sigma. For effective stress, sigma 3 dash and sigma 1 dash, you just need to subtract pore pressure from the total stress. So for test 1, the chamber pressure sigma 3 is directly given 80, sigma 1 dash is 80 plus 175. Third column, sigma 3 dash is 80 minus 45, 35, and sigma 1 dash is 212. So you can see just by using the two formulae, we have found out the stresses for plotting the graph. Now you can do the same calculation for test 2 and also for test 3. Now it's time to plot the graph. I'll show you the answer first. So this is how the graph will look at the end. Now we'll learn how to plot it. So if you have a graph sheet, you can use it, or you can directly plot axis in your notebook. So x-axis is the normal stress and y-axis is the shear stress tau. You first need to find the maximum value in the table, maximum stress. Accordingly, you choose a suitable scale and suitable interval. So we'll start with the first test for the total stress. So sigma 3 is 80 and sigma 1 is 255. So plot on your graph the first point sigma 3 80 and sigma 1 255. Now you have to plot a circle, so for that you need a center. So you can take an average, you will get a point. Then from that center you can draw a semicircle. So this is the step you have to follow for all the tests. Now for test 2, the total stress, you will have a bigger circle and even more bigger for test 3. Now once you have these 3 circles for total stress, you need to draw a failure envelope. So it's a line which touches all the 3 circles tangentially and cuts the y-axis. So it's like this. Now the way it cuts y-axis is cohesion, and the angle which it makes with the horizontal is phi. Now similarly, we'll repeat the procedure for effective stress. So for the first test number 1, you have to plot sigma 3 dash 35 and sigma 1 dash 210. Again, by taking average, you will get the center, and using that center, you can draw a circle. Now similarly, for test 2, test 3, you can draw the more circles. Again, to draw the failure envelope, you need to draw a line touching all the 3 and cutting y-axis. So now we have 2 failure envelopes, one for total stress and one for effective stress. With this you can find C, C dash and phi, phi dash. This is how it will look. So if you can measure in your graph sheet now using protractor, you can find the values of C and phi. The values you must get are around C for 50 and phi 18 for and C dash 60 and phi dash 20 respectively for effective stress. So with this we end this video. In the next video we'll be solving problem on direct shear test.